What's up, team? Today we're talking about slope-intercept. Now, if somebody were to ask me, like, what is the most important topic in Algebra 1? Something that you're going to use the most, both throughout your math journey and then beyond that, I would say the ability to interpret and then use slope-intercept form. So that's understanding the graph side of it, that's understanding what the different pieces of it mean. So slope-intercept form, this is a huge, big topic. I know I've said that before, and I've meant it every time, but slope-intercept form is a huge, big deal. So make sure that you're dialed in, make sure you understand the different pieces of this lesson. Okay, you can see the learning target above. It says, I can identify the slope of a line and the y-intercept when given the equation of a line in slope-intercept form, and I can write the equation, the equation of a line in slope-intercept form. So I know that seems like a lot. That seems really overwhelming. I'm here to tell you it shouldn't be that challenging based on the things that we've learned prior to this point. We're familiar with slope, or we're familiar with y-intercepts. Now we're just going to put it together within the equation of a line. All right, so what is slope-intercept form? Slope-intercept form looks like this. Y equals mx plus b. This is a phrase you're going to hear a lot throughout your rest of your math journey. Y equals mx plus b, y equals mx plus b. If you haven't heard it already, you're going to hear it so many more times. So make sure that this gets in your notebook. I need you to have this written down. And I'm going to explain like what all of this means as well, like how to interpret what's going on. Well, the x and the y, we already know how to use x's and y's. X is going to be our input, y is going to be our output. So x is going to change over time. We're going to plug different x's into this thing, and then this can be multiplied by whatever the m value is, and we're going to add b to it. But in slope-intercept form, these things have very particular meanings here. So I'm going to write some of them in. N is always going to be the slope. Always, always, always. If you hear, m equals blah, we're more than likely talking about slope. Now, the question always rises, why is m slope? Well, why don't we call it s? Good question, and I actually don't know the answer to it. But in the context of algebra and math in general, n almost always refers to slope. Now, the y-intercept is this b term. Y-intercept. And it's going to be at, the y-intercept is at the point 0, b. So the y value, wherever the line crosses the y-axis, is going to be this b value. So in order to write the equation of a line in slope-intercept form, you only need two pieces of information. You need the slope and you need the y-intercept. And you can just plug and play. You can create the equation of any straight line using this form right here. As long as you have the correct pieces of information, you just plug the pieces in and you can describe any linear function using this equation. All right, now I'd like to go through a few examples. So here's an example of an equation in slope-intercept form. Remember, y equals mx plus b, and our task is to identify what the slope is and what the y-intercept is. So as we read it out, y equals mx plus b, we know that the slope is our m value. In this case, the slope, that's the number that's attached to the x or being multiplied by x. So our slope is 20. Or if you want to think about it in rise over run form, you could put 20 over 1. Those have the same value. So the number that's being multiplied by x, that's our slope. That's it. That's all we need to determine here. The y-intercept, well, that's going to be the number at the end, but it's not quite that simple. We can't just write 5 in this case. Because the y-intercept has an x-coordinate and a y-coordinate. The cool thing about it, the y-intercept always has a x-coordinate of 0. So the y-intercept is going to be 0, 5. Where the 5, this is where the 5 comes from, is the b term, and the 0, it's always going to be 0 because the y-intercept always has an x-coordinate of 0. Here's a second example. Y equals 3/4 x minus 11. So what's our slope? Well, it's the number that's attached to the x. It's our m value, 3/4. And the y-intercept here, well, we know it's going to be 0, something, because it always is. That's just how y-intercepts are. It's the definition of a y-intercept. 0, something, and that's going to be our b value here. The kicker with this one is that it's negative, so we need our y-intercept to reflect that. Y-intercept is at 0, negative 11. Slope is at 3/4. Here's our next one. Y equals negative 7/3 x plus 1/2. Well, our slope, it's still the number that's being multiplied by x. In this case, it's a fraction and it's a negative fraction. That's okay, we just need to reflect all those pieces. So negative 7/3. That's our slope. If you do some rise over run, you're going to go down 7 and to the right 3. Easy peasy. Y-intercept, we know it's going to be 0 comma something. In this case, the something happens to be a fraction as well. That's okay. It's positive, so it's positive 1/2. There we go. Okay, for this example, I want to flip the script a little bit. What if you're given that you have a slope of 5, you have a y-intercept of 0, negative 1, and your task is to write the equation of the line? Well, we know that the general equation of the line is y equals mx plus b, and we just need to plug in the m and the b. Well, we're given the m and we're given the b. So our equation of this line with a slope of 5 and the y-intercept of 0, negative 1 is y equals 5x minus 1. All right, here's our final example. This time we're given a line on a graph, and our task is to write the equation of this line in slope-intercept form. So we need to find two pieces of important information. We need the slope, we need the y-intercept. So we know it's going to be in the form of y equals mx plus b. We need to find our m, we need to find our b. So let's start with the b. I think it's going to be the easiest to find. That's just wherever the line crosses the y-axis. The y-axis is the vertical one, and our line crosses the y-axis right here at negative 1, negative 2. So the b is going to be at negative 2 because our y-intercept is at this point 0, comma, negative 2. So the b, negative 2, that's where it's going to go. Cool. Let's go find the m now. M is the slope of the line. So we can find the slope of this line doing a little bit of rise over run. So if I start at this point here and I'm going to this point right here, so I'm starting at 0, 2, and I'm going to this one, which is at 3, 0. I'll label that. So doing a little bit of rise over run, reading from left to right. For this point to be at the same height, we have to go up 2. So we're rising 2, and then we're going to run 1, 2, 3. So our m, we rise 2, and we run 3. So our slope is just 2/3. Now we plug in the pieces. Y equals 2/3 x minus 2. This is the equation of the line. And just for funsies here, the reason that this is the equation for the line is because you can plug in any x value in for x and plug it through this function, and you're going to find out what the output of the y value is. For example, if I plug in 7 to this here, I'm not going to do all the math, but if I did, I would determine that the output, the y value in x is 7, is whatever this y value is right there. Now, it might not be exactly 1, 2, 3, 4. That's because I'm not a computer. I just drew this by hand. But it's going to be somewhere right in there if this was a perfectly straight line and all of that. And that's the value of these functions.